Bismillahirrahmanirrahim. Assalamu alaikum and a very good morning to all of you. I am Amjad Ali here from Doha, Qatar. We were discussing about the atomic structure, unit number 211, grade chemistry. And now we reached at the end of this unit. Today we are going to study last topic of this unit, electronic configuration. So first of all, you will know what is the electronic configuration. Electronic configuration is the arrangement of electrons in different orbitals. So first of all, here I share with you energy sequence diagram of the different atomic orbitals. So we must follow this one. Look at here, for example, if the value of n is 1, so then first energy level is 1s, and then for n2 it is 2s and 2p, then 3s, 3p, 3d, 4s, go on. So we can memorize this energy sequence diagram, or even we can memorize simply, like for example we can start 1s2, 2s2, 2p6 and going on. So first of all, if you know if the sequence of these atomic orbital, then you should be able to write the electronic configurations. But we must follow the rules to fill the electrons in the atomic orbitals. N plus L rule is a very important rule. As regard of examination point of view, many times it's there as a short question. What is N plus L rule? N plus L rule is, if we want to fill the electrons in the orbitals, we must follow this rule n plus L. So according to this one, electron will fill in that orbital which will have less value of n plus L, like for example 2s and 3d. For 2s, n plus L value is 2, and for 3d, n plus L value is 3 plus 2, 5. So value of n plus L 2 is less, it is for 2s. So electron first fill the 2s instead of 3d. So it is n plus L rule. And if for example there are two orbitals and that have same value for n plus L, so then first we fill that orbital which has the less value of n. So it is n plus L rule. More, sometime when students are writing electronic configurations, so question come in their mind, why 4s orbital having the lower energy than that of the 3d. So normally if we are writing the electronic configuration, we think that 3d may come first, but we supposed to write first 4s and then 3d. So the reason is again same n plus L rule. If we calculate the value for 4s, so according to the n plus, its value is 4. Look, for 4s the value of n is 4 and L 0, so total sum is 4. And for 3d, n value is 3 and L value is 2 and sum is 5. So look at here, according to the n plus L value, so for this one 4s the value is less, so first it will fill with the electron and 3d will be later. There are more rules to fill the electrons in the different orbital to write the electronic configuration, like off by principle. Off by principle is simple, even it was there in 9th grade book. So electron always fill in this way, so lower energy orbital will be filled first and higher energy will be later. One more principle is there, that is called Pauli's exclusion principle. According to this principle, no two electrons in the same atom can have the same value for all quantum number. So it's not possible for two electrons, they may have the same value for all quantum number. Minimum the s quantum number, it must have the two value, plus half and minus half. So 50% will move clockwise and 50% will move anti-clockwise. And another important rule is here, that is called Hund's rule. What is Hund's rule? Hund's rule is this one. If suppose degenerated orbitals are available, degenerated mean orbital having the same energy are available, then electron will fill in those orbital like this one unpaired and separately instead of like this one. So it means that this arrangement according to the Hertz, like electron fill separate in degenerate orbital instead of like this one. So it is correct and it is wrong. I can show you one more slide as regard of the Hertz rule. So look at here. Same thing. If degenerate orbitals are available for the electron, then electron would like to live in separate orbital rather than they fill the one orbital. So look at here. For example, it is look 2p orbital are 3, 1, 2 and 3 and all are degenerated having same energy and you 2 electrons supposed to fill there. So it will be wrong. Those 2 electron will fill separate like one in this one. Look, so it will be correct according to the Hund's rule and this will be wrong according to the Hund's rule. When we learn about these rules, then we will be able to write the electronic configurations of the different orbital. For example, it is calcium having atomic number 20. So according to the 20 atomic number, we can write the electronic configuration like 1s2, 2s2, 2p6, 3s2, 3p, 3s2, 3p6 and 4s2. So for calcium, the outermost orbital is 4s2 having the 2 electron. So it belongs to second group of the periodic table. And for another, for example, if you want to write the electronic configuration for scandium, scandium having atomic number 21. So now here we suppose to fill the electron 21. So 21 means same 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and then 3d. Look, first the 4s it will filled and later 3d will come and filled with the electron. So up till here already 20 electron was there like in the calcium. So just one electron is extra that will come in the d orbital. So it's the electronic configuration of the scandium. One more example I can give you as regard of electronic configuration. Look at here, it is Mn, manganese. So its atomic number is 25. So how we can write its electronic configuration? Look, same 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and remaining 5 will fill in the d orbitals. Now for example, whenever if you want to change the manganese into Mn plus 1, so electron first will remove from the 4s orbital, not from the d orbital. So it is the electronic configuration of the manganese. So in this way I have explained you the topic of the electronic configurations, and with this one we have end this chapter atomic structures. Hopefully you have understand these. So take care of you, take care of the people around you. Inshallah next I will present my lecture as regard of the hybridization theory. Okay, Allah Hafiz.